Hi guys and girls, it's your teacher, Mr. Hers. You thought I was gone today, didn't you? Nope, I'm here, and I'm watching you, so behave. Gonna give you a little notes today. These are gonna go pretty quick, but the good news is if you wanna watch this video again, it's on YouTube. The whole world can see this. Hopefully, it goes viral and I have 5 million views. And don't even think about disliking it at the bottom of this video. Thanks. Okay, moving on. Okay, what we're going to do today is classify different types of lines and then angle relationships, kind of broken up into two sections here, this section. Okay, first off, parallel lines, something you already know, are lines that don't intersect and are coplanar. And what that means is if we go down here to this cube, letter A is asking what line is parallel to AB and contains E. And by the way, this should have a line over it. Okay, but parallel to AB and contains E is this segment EF. Okay, going on the same plane, never going to intersect. Okay, the only line in this diagram that is parallel to AB and contains E is this one right here. Okay, now other lines in this cube that are parallel to AB are like CD, on the same plane as AB. Okay, but also this is one people don't notice. GH is also parallel to AB because although there's not a plane drawn, I could create a little plane right there. Okay, so understand that. So parallel lines are lines that don't intersect and are on the same plane, and here's the symbol for parallel right here. Okay, so we would say like AB is parallel to CD. Something like that. Okay, so know the symbol for parallel. Okay, now skew lines, this is new, are lines that do not intersect and are not coplanar. So here's what we have here. If I am, that's in letter C down here, we want a line that's skew to AB and contains E. Okay, should have that. So AB's here, and skew, we want to picture like going in different directions, like airplane flying in a completely different direction, and here's what it would look like right here. This is the only line segment in this cube that is skew to AB and contains E. Okay, notice these are on different levels. If you picture airplanes kind of flying in different directions, these will never touch, yet are not on the same plane. Okay, another line that I could, that's skew to both AB and EH, this line back here. Notice, never going to intersect either of those other two lines, right? All three of those lines are skew. So it's kind of hard to visualize in three-dimensional space on a two-dimensional sheet of paper, but you can kind of see how these lines would never intersect but are not on the same plane. So skew, understand that definition. Okay, perpendicular is what it is. We already know what perpendicular means. So we want a line that's perpendicular to AB and contains E, and that's, here's AB again, and that's clearly AE, right, forming a right angle. So, know those three. Two of them you're already pretty familiar with, but skew also. Okay, really quickly I want to show you this. This is a map I found on the internet of all the airplanes that are flying over the United States at a particular time, and this was just taken, who knows when, and there's obviously a ridiculous amount, and the reason that so many of these airplanes can fly over the same space at the same time is because they're flying in skew paths. They're all at different altitudes. Okay, it might only be a couple hundred or thousand, I guess I should say maybe 1,000 or 500 feet difference, but they're all at different levels. So this having skew paths is a big deal when it comes to like flight command and air command, air traffic people. They got to know what they're doing. So I want you to see this kind of stuff as it relates to skew lines. Like all these are flying in skew directions here. Okay, moving on. Okay, so for the last part of our objective, we are going to look at something that's really important to us. Okay, when we have two lines, okay, these two lines, M and N, okay, they're going in somewhat different directions. Now, eventually they're going to intersect over here somewhere, and we get that. Okay, but for the most part, we're looking where they don't intersect. Okay, and then we are also looking at this line P that is intersecting both of these two lines. Okay, now this is very important to us in geometry, and this line P that intersects these two lines M and N, this line is called a transversal. Okay, so write this down. Hopefully you got this diagram in your notes. Transversal, and I have it written down here. A transversal is a line that intersects two or more coplanar lines. So P is acting as what we call a transversal in this diagram. And then you notice what's formed here is 8 angles, right? 1, 2, 3, 4 is top group. Okay. And then 5, 6, 7, 8 is bottom group. Okay, and it turns out that these angles have relationships to one another that we're going to learn today. And then when these lines become parallel, when M and N become parallel, some really important things happen to these angles. And we won't talk about that till next section, but for now, we have to at least know how to name these angle relationships. So I'm going to do some erasing here. Let's see. Let's get a thick eraser. Okay, good. Alright, so here we go. The first relationship that we're going to learn is something called corresponding angles. And when we have a transversal intersecting our two lines, we have common positions of angles. For instance, notice that angle 1 and angle 5 are both in the top left position of their group of 4. Okay, so angle 1 and angle 5 would be considered corresponding with one another. Okay, notice that 2 and 6 are in the top right position of their grouping, so they would also be corresponding. Notice that 3 and 7 are in the bottom left position of their grouping, so they would be corresponding, and 4 and 8 are both in the bottom right, so they would be considered corresponding. Okay, so understand that corresponding angles are a pair of angles that are in the same position of their grouping when the two lines are intersected by the transversal. Okay, and here we have which angles are corresponding with one another. Okay, so now, next relationship is called alternate interior angles. Now, I'm going to do some erasing up here. Let's see. Bear with me. Come on. Alright. It's not going to let me erase that, but that's okay. Okay, so we have space that's interior to our two lines, here and here. And then I'll draw in like blue space that's not interior to our two lines, space that would be exterior. Like all the space on the outside of these two lines would be exterior space. Okay, so when we talk about alternate interior angles, 3 and 6, I'm going to stick with blue here. 3 and 6 would be considered alternate interior angles because they are on the interior of our two lines, M and they are on alternate sides of the transversal. Okay, notice they're on different sides. 3 is on the left side of the transversal, 6 is on the right side of the transversal. Okay, so these are considered alternate interior angles. Okay, again, it's just really important that we have these names down, and kind of how these angles relate to one another doesn't get important until next section, but we at least have to be able to identify what's what. Okay, similarly to 3 and 6, notice angle 4 and angle 5 are also what we call alternate interior angles because they are on the interior of our two lines and on alternate sides of our transversal. Okay. Let's keep it going. Alternate exterior angles, 1 and 8 and 2 and 7. Okay. Alternate exterior angles are on the exterior of our two lines and on different sides of the transversal. So look at 1 and 8. 1's on the left side of the transversal, 8's on the right side, and they're both exterior to our two lines. Same with 2 and 7. So 2 and 7 would be alternate exterior angles with one another. Okay, and finally, we have what we call consecutive or same side interior angles. Okay, so same side or consecutive interior angles. Let's do this in like green. okay, would be interior to our two lines and on the same side of the transversal. So 3 and 5 are same side interior, and 4 and 6 are same side interior. Okay, so understand kind of how these things get named, and you'll practice that tonight. In fact, I'll throw it up here and have you practice. Okay. All right, last slide, guys. We have another pair of lines, and I don't have them named here, but another transversal kind of going horizontally here, and then thus we have another grouping of angles here and grouping of angles here, and thus we have some angle pair relationships that we can name. So I want you to name or list the pairs of corresponding angles. There's 4 pairs. List the pairs of alternate exterior angles, list the pairs of alternate interior angles, and list the pairs of consecutive interior angles. And just to give you a hint, there's 4 pairs here, but there's only 2 pairs of 2, 3, and 4. Okay, so good luck. Hopefully you come up with the right answer, and we'll check back here in just a minute. Okay, go ahead and pause the video for a sec. Make sure you get that right here. I'll have you do that. Okay, see it right? Okay, we'll come back here in a minute and make sure you got it right. Okay, hopefully for corresponding angles, I'm going to do this in black. Hopefully you had angle 1 and angle 3 corresponding, angle 2 and angle 4 corresponding, angle 5 and angle 7 corresponding, and finally angle 6 and angle 8 corresponding with one another. If you did, good job. The alternate exterior angles would be angle 1 and angle 8 and angle 4 and angle 5. Okay, the alternate interior angles would be 2 and 7 and 3 and 6. Okay, 2 and 7, 3 and 6. And finally the consecutive, there you go. The consecutive interior angles would be angles 2 and 3 and angles 6 and 7. Okay, hopefully you got that. That's what you need to get out of today, basically. Understand parallel, perpendicular, and skew, and understand when we have 2 lines intersected by a transversal, being able to name our angle pairs. Okay, we'll come back and talk tomorrow. Hope you have a great day. Goodbye. Oh boy.